Welcome to Unit 5 APES interview. Today I will be asking you questions about Unit 5. My name is Sharath and I will be your interviewer today. Okay, let's begin with tragedy of the commons. Evaluate how the tragedy of the common demonstrate a failure of shared resource management in human societies.
The tragedy of the commons demonstrates a failure of shared resource management in individuals because they act in rational self-interest, which inevitably exploits and depletes a shared finite resource. This occurs because the immediate gain of maximizing resource use causes the individual, while the cost of resource degradation is distributed among all users, as seen with overfishing because it causes the eventual collapse of a common fishery while everyone else is short-term benefited.
Propose one policy or community strategy that could prevent this outcome in a modern context.
One strategy that could prevent this tragedy of the commons is implementing a limited access policy supported by a quota system, such as the individual transferable quotas. For example, in New Zealand's commercial fishing industry, this policy privatizes the right to access a specific portion of the resource, giving holders a specific economic interest in the long-term sustainability of fish.
Now let's move on to clear cutting. Access how clear cutting provides short-term benefits but undermines long-term ecosystem services.
Clear-cutting offers short-term economic benefits by maximizing timber yield, but it severely undermines long-term ecosystem services by completely destroying forest habitat and releasing significant stored carbon. This practice can lead to high rates of soil erosion and stream sedimentation, which pollutes aquatic ecosystem and degrades watershed crucial water services.
Suggest one sustainable forestry method that could protect biodiversity while maintaining resource access.
A sustainable method that protects biodiversity while maintaining resource access is selective cutting, where only mature or specific species of trees are harvested, leaving a structurally and diverse forest canopy intact, which preserves habitat, minimizes soil disturbance, and allows for continuous natural regeneration.
Analyze how the Green Revolution reshaped agriculture efficiency and environmental health on a global scale.
The Green Revolution revolutionized agriculture by using high-yield varieties, synthetic fertilizers, pesticides, and irrigation to achieve a massive increase in global food production. However, this efficiency came at a high environmental cost because increasing heavy reliance on fossil fuels, extensive water depletion can lead to eutrophication and a loss of agrobiodiversity from monoculture farming.
Define whether or not the overall legacy of a Green Revolution is positive for the environment.
The overall legacy of the Green Revolution is arguably negative because despite its humanitarian success in feeding a rapidly growing population, its methods create an unsustainable and resource-intensive problem, as well as heavy agricultural issues that contribute to drive habitat loss, soil degradation, and climate change acceleration.
Now let's move on to agricultural practices. Compare the environmental trade-offs between traditional and modern farming practices such as tilling, fertilizer use, or slash and burn.
Traditional practices like slash and burn offer the environmental benefit of short-term soil fertility and low input costs, but cause a significant trade-off in the long term through deforestation and the rapid release of stored carbon, while extensive modern practices like tilling enhance productivity but lead to severe soil oxidation and erosion, and the use of synthetic fertilizers avoids the limitations of organic manure but also causes widespread water pollution and nitrous oxide emissions.
Recommend one innovative solution that could balance productivity and sustainability.
One solution that balances productivity and sustainability is the adoption of precision agriculture as well as no-till farming, which uses GPS and remote sensing technology to apply precisely the right amount of fertilizer and water to specific areas, which thus maximizes yields while simultaneously minimizing the waste and preserving the soil structure.
Let's move on to irrigation methods. Examine how irrigation practices affect both local water resources and soil health.
Irrigation practices can significantly affect local water resources by depleting aquifers or diverting surface water, which leads to regional water scarcity while simultaneously impacting soil health through waterlogging. More commonly, in arid regions through salinization, where the evaporation of irrigation water leaves behind toxic salt concentrations on the soil surface.
If you are designing a farm in an arid region, which irrigation method would you choose and why?
If I was to design a farm in an arid region, I would use drip irrigation because it is the most efficient method since it delivers water directly to the plant root zone via slow releasing emitters. This minimizes water loss from evaporation and runoff, thus conserving critically limited local water resources and significantly reducing the risk of destructive salinization.
Let's move on to pest control methods. Evaluate how pesticide resistance evolves and how it affects global food security.
Pesticide resistance evolves through natural selection as repeated pesticide application kills susceptible individuals, leaving only those with a genetic mutation for resistance to survive. As a result, this evolutionary race diminishes the effectiveness of chemical controls, requiring higher or new chemicals, which can thus threaten global food security by increasing crop loss and dramatically raising economic costs of pest management.
Propose an integrated approach that minimizes resistance while maintaining crop yields.
An integrated pest management approach that minimizes resistance while maintaining crop yields by combining multiple tactics, such as introducing biological control agents. These agents can include planting pest-resistant crop varieties and using pesticides sparingly and strategically only when these populations reach a threshold, which therefore reduces selective pressure on the pest population.
Meat production and analyze the environmental, economic, and ethical trade-offs between CFOs and free-range grazing systems.
Concentrated animal feeding operations, also known as CAFOs, offer economic benefits through rapid production scale and lower consumer prices, but they can also create severe environmental trade-offs, including massive greenhouse gas emissions, extensive water pollution, and high ethical costs regarding animal welfare. However, free-range grazing offers environmental benefits like improved soil health and carbon sequestration if managed properly, along with higher animal welfare, but this can also cause economic trade-offs since higher land requirements are required as well as slow production cycles.
Predict how reducing global meat consumption might reshape ecosystems and resource use.
Reducing global meat consumption would significantly reshape ecosystems by allowing deforested land currently used for pasture and feed crops to be purposed for reforestation or sustainable crop production. This will lead to a massive decrease in global eutrophication and a substantial reduction in massive water and land resources currently used for animal agriculture.
Overfishing. Access how overfishing alters marine food webs and impact human economies.
Overfishing can significantly alter marine food webs through trophic cascades, often by removing apex predators or keystone species, which can cause unnatural increases in lower trophic level organisms such as jellyfish and destabilize the entire ecosystem. As a result, this can impact human economies by leading to the collapse of commercial fishes, causing widespread job losses and reducing long-term protein availability for several coastal communities.
Design one international policy that could help sustain fisheries for future generations.
An effective policy to sustain fisheries is a globally enforced marine protected area network, which establishes strategic large-scale no-take zones and critical spawning and nursery grounds. In addition, an agreement among all major fishing nations to utilize science-based quotas would strictly eliminate illegal, unreported, and unregulated fishing.
Explain how mining operation both fuel economic development and degrade natural systems.
Mining operations fuel economic development by providing raw materials for infrastructure as well as contributing through national GDPs. However, they can degrade natural systems through habitat destruction and deforestation, which can also lead to acid mine drainage and the contamination of surface and groundwater, which can thus affect local ecosystems.
Evaluate which solution, technological innovation, regulation, or community action, could most effectively reduce these impacts.
While all of these are necessary, strong regulation would be the most effective, as mandatory policies can help create a non-negotiable legal framework that forces even several companies to internalize environmental cost mitigation. While on the other hand, innovation and community action often lack necessary global scale or financial leverage.
Finally, let's end with urbanization. Examine how urban growth influences the carbon and hydrologic cycles on a regional scale.
Urban growth can influence carbon cycle on a regional scale by increasing concentration of impervious surfaces, which can produce the urban heat island effect and raise energy demand for cooling, which thus causes more fossil fuel combustion. It also influences the hydrologic cycle by replacing permeable soil with more runoff and decreasing groundwater recharge, often causing more frequent flooding.
Propose a city planning strategy that could make urban areas more resilient to environmental change.
A resilient city planning strategy is the widespread implementation of green infrastructure, specifically by using permeable paving or green roofs. We can collectively intercept stormwater runoff, increase evapotranspiration, overall reduce the urban heat island effect, and allow for natural filtration and groundwater replenishment. Thank you for your time.
Welcome. Good job.
Sorry.